Hi everyone, and welcome to today's tutorial on parallel programming in C++. If you've ever wondered how to make your programs run faster by executing multiple tasks simultaneously, you're in the right place. Today, we'll dive into std, async, an elegant tool in C++ that simplifies concurrency by letting you run tasks in parallel without the headaches of managing threads manually. Whether you're an experienced developer or just starting out, by the end of this tutorial, you'll know how to use std async to unlock the power of multi-core processors. Let's get started. Let's start with the basics. Std async is part of the C++ standard library and is designed to execute functions or callable objects concurrently. When you call std async, it creates a background task that runs in a separate thread or defers execution until you explicitly request the result. It returns a std future object, a placeholder for the task's eventual result. You can use this future to check the status of the task or retrieve its output once it's complete. Think of it like sending a package through a delivery service. You give the task or package to std async. While it's working in the background, you can do other things. When the package arrives, the task is done, you collect it using the future. This is incredibly useful for intensive computations or tasks that might otherwise block your program. Let's look at a basic example. We'll create a function called compute_square that calculates the square of a number. Instead of calling it directly, we pass it to std async with std launch async. This ensures the function runs in a separate thread, so the main program can continue executing. Here's how it works. While the task is running in the background, the program prints a message, computing square in the background. Later, when we call result.get, the program retrieves the result of the computation. If the task isn't finished yet, get will wait until it's done. This simple example shows how easy it is to run tasks asynchronously. Now, let's take it up a notch by using a lambda function. Instead of writing a separate function, we define the computation inline using a lambda. For example, to calculate the factorial of a number, we write a lambda function that loops through values from 1 to n and multiplies them together. We pass this lambda directly to std async, which runs it in a separate thread. As before, while the computation runs, the program can continue executing other tasks. When we call factorial.get, the program retrieves the result of the factorial calculation. This approach keeps the code compact and easy to read, making it ideal for one-off tasks or quick computations. What if you don't want a task to run immediately? That's where std launch deferred comes in. With deferred execution, the task doesn't run when you create the future. Instead, it waits until you explicitly call result.get. Only then does the computation begin. This is useful when you want to control the timing of a task and ensure it only uses resources when absolutely necessary. Now, let's explore a real-world use case, summing numbers from 1 to 1 million. To speed things up, we divide the task into two parts. The first half of the range, from 1 to 500,000, is handled by one std async call. The second half, from 500,001 to 1 million, is handled by another. Both tasks run in parallel, leveraging the power of multi-core processors. When both computations finish, we combine their results by adding the outputs from first_half.get and second_half.get. This demonstrates how parallel programming can significantly reduce the time needed for large computations. Now that you've seen what std async can do, here are some best practices. Use std launch async for tasks you want to run immediately in a new thread. Use std launch deferred for tasks you want to delay until explicitly needed. Avoid creating too many tasks, each task consumes resources, so be mindful of your system's limits. Parallel programming doesn't have to be complicated. With tools like std async, you can easily break large computations into smaller, faster tasks, taking full advantage of today's multi-core processors. Thanks for tuning in. I hope this guide helped you grasp the basics of parallel programming with std async. If you found this tutorial helpful, Don't forget to like, subscribe, and hit the bell icon for updates on more programming tips and tricks. Have questions? Drop them in the comments, I'd love to help. See you in the next video.